What we're looking at here is a visualization of ocean flow over time. This is actually a part of a NSF-sponsored project on paleoclimatology and paleoceanography. The idea here is to reconstruct flow patterns in the ocean over time from the last ice age to today, essentially, by using sedimentary core samples, which will give us a distribution of radioisotopes. And then we are working with researchers from the Woods Hole Oceanographic Institute who have a method of deducing the flow patterns in the ocean from these isotope ratios and those core samples. And I should mention the core sample database is generated by our other collaborators at UCSB and WHOI. And this particular program that I'm showing here was actually developed by a visiting student from Germany, Rolf Westerteiger. And unfortunately, he had to leave before we could really make a nice video showing the software. But it's so nice that I figured I would stand in and just talk about it well, as if it were my own. So forgive me, Rolf, for saying anything wrong. But I thought this was too important to not have a video, even though Rolf is not here anymore. So what we're looking at here is a globe with the oceans drawn in, well, mostly blue right now what we're seeing, but there's some red in there, I'll explain that. And then the continents are just drawn in gray. And if you pick this up and move it a little bit closer and zoom in a little bit so you can see better, one thing that you obviously notice right away is that the continents are just extremely rough outlines. And that's because the continents are currently defined by the flow field that is driving this visualization. And the flow field is relatively coarse. It's like a couple degrees by a couple degrees resolution. And so the continents are only expressed as missing data blocks in this grid. So in other words, the roughness of these outlines is due to the roughness of the original grid. We have a planning to include a higher resolution bathymetry model into this, so we can more easily see what's going on. But for now, this is the actual data that we're looking at. So then, what we're seeing is, if I pull it up a little bit and zoom in, you can see these. Well, here I'm looking at a particular vortex, where, as you can see, the water is going into swirl, and then essentially converging onto 180, and then at that point it gets sucked sort of into the deeper parts of the ocean. And the visualization method that we're looking at here is called a LIC, which stands for Line Integral Convolution. It's a quite nifty visualization method for two-dimensional and also for three-dimensional vector fields. And this program here that Rolf wrote is very nice because it computes this LIC visualization in real time by using the graphics card that are driving the display. So there's a GPU-based real-time LIC visualization, which is really cool. So the nice thing is you can just by looking at the ocean, and I should mention that the ocean is colored right now by the magnitude of the velocity. So blue are lower magnitudes, water is moving relatively slowly. White are medium magnitude, red. Well, we don't have any red right now. Turn this over. Oh, right, here we go. There's the main Pacific stream. So red means that we have high velocity. And actually, I think I might have said it the other backwards. It might be that red is on the low velocity. Anyway, so this is an animation of the flow. But what we are looking at right now is an animation of the static flow. Even though the flow is changing over time, but we're currently looking at a constant flow pattern because using animation to visualize that. The reason for that is that even though we do have a time series behind here, where we have data of ocean flow from the last ice age to today, the time scale of these time steps that we have, like every couple of thousand years, is really on a whole another different level, a whole another order of magnitude than these smaller scale motions that we see. So I can play that back, but it's not going to be really showing what the flow in the ocean is. I'm going to do that anyway. So now we are seeing how these eddies are moving. But this is not really a realistic motion in real time. This is really going through the centuries and millennia and seeing how the larger patterns in ocean circulation are changing, which is really what this project is all about. So what I also want to do is talk a little bit more about the capabilities of this really nice program. The shell of the ocean that we're looking at here is just the ocean surface, but we can also go through the different depth layers. I can just peel it back by using this pretty involved GUI here, so I can drag the slider, and this will go through the depths of the data set, and you see how more and more of the ocean floor of the solution gets exposed as I go lower in the ocean. And again, you see that this is pretty blocky because it is defined by the data set's resolution. By the way, here we're looking at the Atlantic. This is South America, I should mention that. This is North America. There's Africa right here, Europe up there. So the other thing that you notice is that the speed of the ocean circulation really decreases as you go deep down. So blue is slow velocity, that was correct about that. And the deeper we go, the slower things basically move. And then as you go back up to the surface, then now we can see how things are really moving a lot faster. All right. You can also limit the visualization of the flow to a region of the globe, that is the limiting in latitude and longitude. So I'm going to drag up the left-hand slider, which will cut off where we go, which will cut off things from the bottom. And then the maximum left-hand slider comes from the top, cut things off here. And then also I'm going to limit the longitude, going to go about here and to about here. So now what we have is, I just selected a brick of ocean essentially. You're still seeing the animation. The reason why I did that is, well, this region is interesting because you can see there's a very nice defined eddy in there. But then I can also turn it over and we can look at cross sections of the flow through the depth. And the interesting thing that you can tell here is that things are moving in a very interesting, way, going back and forth. So that is really a very impressive thing that Rolf did there. That you can look at these things, you can look at the flow patterns in real time as we go through geologic time in the ocean. Now, one other visualization method that is often used for looking at flow models like this one is that we can see individual tracer particles, and then we can see how those tracer particles move through the flow. And I'm going to do that here as well. The way we're doing it is just I'm placing myself into the ocean, like this, and then I can just use a button on the input device, and I can press the button here, and the particle gets released right here. Now this particle for some reason is moving at all. Probably because I'm not close enough to the surface. Here we go. As I mentioned, in the deep ocean, things are moving really slowly. So here now I released a couple of other particles, and you can see how they are nicely making their way across here. There's also a way to make these guys go faster. Let's see. There we go. That's more like it. So now we can drop another couple in here. And we can soon go. Let's see, let's go closer to our eddy over there, so we can drop some particles right into that. And let's see what happens if I drop them in here. They should get sucked into this eddy, so let's see what happens. I'm going to drop them here, and yep, there we go. Again, deeper ocean has very slow flow. And so these are generally going in, but then this way are also coming out again. And then here, you can see where they make the turn and go into the eddy. Now, we can make the surface transparent. Just have to drag them to this side again. Very cool. So now we can see the particles as they are inside the box. I'm just going to see a few more, and here they go. Very nice. And you can see how they get sucked in, and then disappear, and essentially stay here. They get swirled around. And in this particular early version of the program, I need to mention that the Z component of the flow, meaning the water that goes up or down in the ocean, is not in the data right now because we weren't quite sure of the scaling factor. We still need to sort that out. So right now, these guys, well, they should be getting sucked into the deep here. These guys are just circling around forever and essentially staying at this altitude, well, at this depth. So that's not quite realistic right now. The software is still quite a bit under construction, but it is already very useful of looking at the larger patterns that are happening. And now, of course, you see, because I cranked up the animation speed, the LIC visualization is running really fast. It's running like crazy. So I need to probably turn it up. But that's that. So just minus the fact that we still need a higher resolution symmetry mode. This this is already a very nice visualization of these flow patterns. One other thing I want to mention that is really cool about this is that I mentioned that the flow patterns were deduced from isotope measurements. And another visualization we have here is that we are bringing in those original core samples. I'm going to just select them here. So now what Rolf did is he posted all of these little graphs, all of these little tags that are standing just right now in 3D space, just always looking at me. And there are little bar graphs on there, which are the isotope ratios for the 4 isotopes I selected, which are the old carbon isotope and oxygen isotope, and then from the last ice age, the same value. So we can see how these values have changed over time. And the nifty thing is that these little tabs mark exactly where the isotope was collected. So you can see that there's a lot of collection going on here in the middle of the Atlantic Ocean, along the mid-oceanic ridge, and also along the west coast of Africa, and then the east coast of South America. There's another huge blob of samples right here in the Caribbean. So these are all done by essentially ocean cruisers which drill down and take an actual sample from the ocean floor and then run that through a chemical analysis. If you flip the globe over, you can see that, there's also a bit of collection in the Pacific, but not really all that much. Most of it is currently in the Atlantic. Here we go. So here's the Pacific. There's not very much going on. There's another rash of samples right here around the northeast coast of Australia, and then there are some here around the east coast of Asia, but really not all that many. So what we're going to do in the future is collect more data. That's not up to us. That's up to our collaborators at UC Santa Barbara. And also refine these reconstructions to create better flow models, which is up to our colleagues at the Woods Hole Oceanographic Institute. East Coast. And then we are going to integrate those data into these visualizations of the sea here to allow our colleagues to better understand their reconstruction methods, to better understand the data they collected and so forth. Currently, this program is running in the KeckCAVES at UC Davis, but over the last couple of months, we also went and installed smaller scale versions of VR environments in the offices of our collaborators, both in Santa Barbara and Woods Hole, so that they can run the same software that we do only on a smaller screen, and that they can also work with us on the data in real time by just having sort of a 3D video conference, which I haven't made a video on yet, which will have to happen at some point. All right, that covers it.